Okay, see, so here we had done about the very first functional groups we studied about the, first of all, the nomenclature, how we studied. We studied about meth, eth, prop, but, pent, hex. Okay, up to non and dec. Then the first group, if there are halogens, and the halogens you have X equals to either chlorine, fluorine, bromine, or iodine. So you prefix the word halo. The word halo is prefixed before the parent name. If you have the functional group as OH, they are called as the alcohols. And here, the class of the compounds which contain this OH group, they are called as alcohols, and the name starts with the parent name and ends with OL. The name ends with OL. Okay. Then we studied about the group CHO, the aldehyde group. CHO is called as the aldehyde group, and it is named with AL, the name ending with AL. The structure of this is C double bond O and H. So we observed that it can be present only at the terminal and terminal chain of the branch. Terminal chain. If you have a chain, so at the end of the chain only you can have the CHA group, or at the end of a branch only you can have the CHO group. Then we studied about the COOH, or the carboxylic acid group. CO and OH. This was the carboxylic acid group, and they are named with the formula oic acid. They are named with the name oic acid. The CHO group, or the aldehyde groups, there is a similar group like this, that is ketone. Those are ketones. And in a ketone, you will find that the carbon is attached with oxygen, and then on both the sides, you can have any of the alkyl group. Alkyl group means any of the carbon or carbon chain can be attached to either side of the carbon. Okay. And they are named with the word ONE. On. Ketone from here, ONE. Okay. Now see how to differentiate between them. Uh, Here it is necessary for a ketone, it is necessary to have a carbon attached to carbon. That means the oxygen which is attached with a double bond to a carbon, this carbon should be attached further with only carbon. There should be only carbon atoms. No other element should be present over there. Then only it is a ketone. Okay. So it cannot be present at the terminal ends. It
Sir,
is
can you
present
repeat
in
again?
between. Yeah.
Can you repeat again?
See, if I look, suppose I want any ketone structure. So a ketone means it should be C double bond O, and the two bonds of carbon which are left out. Here you will have carbon only. You can have only carbon, and no other element will be present here. You cannot have the presence of hydrogen or any other element.
Okay.
Okay, so this is a
Okay.
ketone, and these carbon, they can be further bonded to some other carbon chains, or anything can be bonded to them. But this, if you have this structure, so this complete structure is the ketone.
Okay. Only carbon and
Yeah, for the simplest ketone, there has to be three carbons at least. You cannot form a ketone of carbon less than three.
Yes.
yeah.
If you try to form it with two carbon, so you will not be able to form it. Okay. Now let's try to draw the structures. Okay. I'm giving you the sum of the names, and you will be drawing their structures and showing it to me. Okay. Let's see. ethanoic acid, pentanol, I hope you are making all these formula, all these structures. Okay. So these are the structures you need to draw.
Done.
Done. Okay. So I'll now check. I'll check it out now. So everyone is done. Those who have not done can just write down the names and then continue doing till I'm checking. They can show, they can continue doing, and when they have completed, just show their die, all the structures. Ethanoic acid, pentanol, butanol, dichloroethene, bromopentanol, ethyne, propanol, propanon. And another one you have to draw cyclohexene. Draw this also. Cyclohexene, then benzene. Okay, so let's check it out now. Who all have done? So who all have done? Shresi has done, and K. Subha Charvik. Have you done?
No, sir, I did not.
So, how many have you done? How many? Okay, you need the screen. Let's see.
Yes, sir.
That's why I told you first you write down all the names and then keep on making them so that I can check here. So just write down all the names. First one is ethanoic acid. Then you have pentanol, butanol. Okay. So let's draw the structures. So side by side you will also check. Then I will check it finally. Your ethanoic acid. Let's draw the structures one by one. So the first one, see the parent name is ethane. That means there should be two carbon atoms. So you make the two carbon atoms and it's oic acid. So one of the carbon must contain the OOH group. So it becomes COOH. Then bonding with the other carbon and then 3 points are left that will be made as CH3. This is ethanoic acid. Ethanoic acid. Then pentanol. What is so pentane? Charvik, how many carbon atoms should be there in pentane?
5.
5. Okay, so let's make 5 carbon atoms bonded to each other. Okay, then it's Al. So what should be attached?
Pentane E.
No, last we have Al. So that, yeah, at the terminal carbon, we should have the CHO group.
Yes.
Okay. So see the carbon of the CHO group, the carbon of the carboxylic group, they are also counted. Do not think that they are not counted. They are also counted in the parent chain. So here I will not another CHO. I will make my CHO only on this carbon. So it will be C double bond O and H. Okay. So is this complete? Now you just have to add the hydrogen. Here you have CH3, CH2, 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 and that's it. Okay. So Kesuba Charvik, understood now?
Yes, sir. Understood.
Okay.
Do.
So did you get this?
No, sir, I got it.
Okay.
That drop.
Okay, butanol. You will show me butanol. Okay. Make butanol. Any help you need for butanol? Okay, let's see. Shesi, show your answer. Just 1 second. Shesi, 1 second. Okay, sure. So you have ethanoic acid, pentanol, okay, then butanol, fine. Okay, the next one. Dichloroethene, ethane or ethene? I think it's dichloroethene. Just check it.
Yes, sir, ethane.
Ethane or ethene?
It's ethene.
Ethene. You have to make dichloroethene. Okay. Then bromopentanol, bromopentanol. Okay. Ethyne, fine. Propanol. Okay. And at the end you have propanol. Okay, fine. All are correct. All are correct. Benzene. Okay, this one is also correct. Okay. Anyone else has completed? Medha Hansini, can you show your answer?
No, sir, I didn't done. I need to do more stuff.
Okay, so okay. See, Medha Hansini, if you have not understood any of them,
Sir, I
Just
understood, sir. I'm just doing it.
Sir, can I show?
yeah, Mehak. And Srilasya, have you done?
Yes, sir, almost.
Okay. So, Mehak, just one. Ethanoic acid, pentanol, butanol. Your butanol is incorrect. Check your butanol. Butanol. Okay. Why it's incorrect? See, this for the ketone group, the double bond oxygen should not be bonded to the terminal one. It should be bonded to any of the inner ones. So either you can make it with the second or you can make it with the third. Okay. So do that. K. Subha Charvik, can you show your how much you have done?
Sir, I've not it properly. I was practicing.
Whatever you have done, you show it so that I'll come to know what all things you have understood or what thing is required for you. Okay. If you have not understood anything, so I will tell you that part.
Like I was doing it this board like this. So I was sorry.
Okay. Show this. I think this was correct one. What was the name given? What's the
Brutal,
name?
I was
What's the name for this?
brutal.
Butanol.
Butanol.
Okay.
No,
Butanol. Fine. This is butanol or butanol.
butanol.
Butanol. L.
Yes.
Okay. Make butanol.
Okay.
Okay. Kesu Bachar, make butanol and show.
Okay.
It's very easy. Again, I'm explaining to everyone. See. Rene, have you done? Rene, is it done for you?
No, sir.
Okay. How many have you done? Okay, just see. Again, have a look. See, this one was your pentanol. This one is pentanol. Then you have to make butanol. So butanol will be made something like this. Butane means there are four carbon atoms. You make four carbon atoms. Okay. Now it's ONE. So ONE represents a ketone. Okay. And a ketone have a general formula like this: C double bond O, and on both the sides there should be carbon atoms only. There cannot be anything other than the carbon. Okay. So for this, as you can see, there are four carbon atoms. So this double bond O should be made on which of them? On this, it can be made only on this or on this. It cannot be made over here or here. It can be made only on these two. So let's make this over here. So once we make the double bond O with the carbon, now you can see that the other carbon, with the other carbon atom, what's happening? So the valency of this carbon is satisfied. It has made four bonds. One, two, three, and four. And a carbon can make at the most four bonds only. It cannot make a bond uh, greater than that. Okay. So carbon will form at the most four bonds like this. And then as you can observe, this carbon, it is lagging with two bonds. So it will have two hydrogen. This carbon will have three hydrogen, and this carbon will have three hydrogen, and hence you have the structure of butanol. Okay, so K. Subha Charvik, understood?
Yes, sir. Understood.
Tomorrow I will ask, or in the next class, I will ask you about all the functional groups. This thing I will ask you.
Okay, sir.
Okay, I will ask you what is the name of the functional group, how it is made, its formula, and its nomenclature.
Okay, sir.
Okay,
So
so
once
keep
can
this
you tell cyclohexene?
cyclohexane or hexene.
Hexene, sir.
Okay, so it's a cyclohexene. So hex means six. There have to be six carbon atoms. It has to be a cyclic compound. Okay, so you have to join them like this. The six carbon molecule, they have to be joined like this. Okay, then you have to make a double bond. So at between any of the carbon, you make a double bond and then add hydrogen accordingly. Wherever the remaining bonds are there, you make their hydrogen. So with this carbon, you have just one bond remaining, you attach one hydrogen. With this carbon, just one bond is remaining, so attach one hydrogen. Now with this carbon and carbon, there are two bonds which are remaining. So you have CH2, here also you have CH2, here also you have CH2, here also CH2. Okay. So this is the structure of a cyclohexene.
So why we need to take double bond in the middle?
Sir, why double bond came in middle? Sir, I'm not.
Where double bond should be made?
Here, chlorohexane, that one in middle, double bond is came. So why
Okay,
I'm not?
okay, so understand each word. First of all, you have cyclo, so it has to be a cyclic compound. Then
Okay,
there is hex. Hex means there have to be six carbon
six.
atom. Then there after that it is ene, E-N-E.
Okay,
Okay,
okay.
so
Yes,
if there is single bond, then you will have an. If there is double bond, then you will have ene. And if there is triple bond, then you will have ine.
yes. Understood.
Understood?
Yes,
Then benzene, see, it has its different nomenclature. It does not follow these rules. Okay, it has a different nomenclature only. So benzene has its such compounds, they are called as aromatic compounds. The compounds of benzene, they are called aromatic compounds and they are made like this. With each at each corner you have a carbon atom. Okay, so make it like this. Carbon, just make it like this. Then attach a double alternate double bonds. Okay, there have to be alternate double bonds. Now you can see that all
So
the carbon,
benzene formula is C6H6.
benzene form it's C6H6.
Is it correct?
Yeah, it's
Yes.
C6H6. There are six carbon atoms with six hydrogen atoms. So each carbon with one hydrogen bonding to it. So CH everywhere. Okay. Any doubts? Any other doubt to anyone? K. Subhacharvi, can you draw ethine?
yes, right.
Okay. Draw ethine. Okay, so understood this much? Made ethine. K Subhacharik, have you made ethine?
Yeah, sir.
Okay, just show. Okay, it's correct. Correct. Okay. So I think almost everyone has understood. See this bromopentenal. It's not pentanal, it's pentenal. Pentene. Okay. So there you have to introduce a double bond. Okay. So I think everyone has now understood about the nomenclature of the organic compounds. Anyone having any issues with the nomenclature? Now we can move further. Okay. Let's see the next topic, the difference between saturated and unsaturated hydrocarbons. What do we mean by saturated and unsaturated hydrocarbons? And what are the physical and chemical differences between them?
Saturated is single bonds and unsaturated is double or triple bonds.
Okay, saturated and unsaturated. So what are saturated? What are saturated hydrocarbons?
So saturated hydrocarbon is single bond.
No. Saturated, they have only double, so they have only single bonded carbon atoms. Okay. So if carbon and carbon atoms, they are bonded with each other all by a single bond. So such compounds, they are called as saturated. So if you observe like this, carbon, 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 carbon everywhere. So this is a saturated hydrocarbon. Okay. Otherwise, if you observe like this, carbon, carbon, anywhere a double bond. So this is an unsaturated. If you observe like this, so this is also unsaturated. These are also unsaturated. Okay. So such things, they are saturated hydrocarbons. And this one is an unsaturated. This one is an unsaturated hydrocarbon. So understood both of them, saturated and unsaturated. Okay. So what are the physical differences between saturated and unsaturated hydrocarbon? What are the differences in their physical properties? Mehak, can you give the differences between physical differences between saturated and unsaturated hydrocarbons?
Sir,
Yes.
sir, you termed the saturated and unsaturated opposites, sir. That will be saturated and that will
Oh,
be
oh, oh,
unsaturated.
oh, yes, yes, yes. Fine. I spoke it correctly, but I named it incorrectly. So these ones are unsaturated and this one is saturated. Okay, so can you give the differences between saturated and unsaturated?
So saturated burns with a clear flame.
I want physical difference.
Oh,
Any physical differences between saturated and unsaturated?
So saturated hydrocarbons are more stable.
Stable in what sense? See, you can talk of their boiling points. So the saturated hydrocarbons, they generally have a higher boiling point than the unsaturated hydrocarbons.
Yes.
Okay. Then second thing you can see about the saturated and unsaturated hydrocarbons, that is the chemical behavior. In the chemical behavior, you can see their flame test. The saturated hydrocarbons, they burn with the blue flame. The unsaturated hydrocarbons, they burn with an yellow flame and produce a black colored soot. Also, the unsaturated hydrocarbons, they undergo addition reaction, whereas the saturated hydrocarbons, they undergo elimination reaction. So write them as the differences between saturated and unsaturated. So understood the difference between saturated and unsaturated?
Yes.
Okay. Now
Yes.
let's see the oxidation reactions. Okay. See the oxidation reaction. If you see, learn it something like this. First of all, you have your alkanes or hydrocarbons. You can have alkanes or alkynes. Then in the next one, after alkenes and alkynes, then the next you get as the alcohols. The next one is aldehydes. Then after that, you move finally to the carboxylic acids. Okay. At the end, even after that, you will get your carbon dioxide and water. So learn it like this. So from the alcohols, you can obtain aldehydes also. From the alcohols, you can directly obtain carboxylic acids. And from the alcohols, you can directly obtain carbon dioxide and water also. Okay. So first of all, we see this process, how from the alcohols you can obtain the aldehydes, you can obtain the carboxylic acids, and you can obtain carbon dioxide. Okay. So the very first step, if we go alcohols, and you want your product as aldehydes only. So alcohols can be converted to aldehydes in the presence of chromium anhydride, CrO3. This is chromium anhydride. The step of the oxidation is it stops at the aldehydic stage. This is also called as a controlled oxidation of alcohol. So by this method, alcohols can be converted to aldehydes in the presence of chromium anhydride. Then alcohols, they can be converted to carboxylic acids. They get converted to carboxylic acids in the presence of alkaline KMnO4. Since alkaline KMnO4, it is a strong oxidizing agent. So it will give you carboxylic acid. CrO3, it is an oxidizing agent, but not a strong oxidizing agent. So therefore, you will be getting aldehydes in the first one. If you use alkaline KMnO4, you get carboxylic acid. Okay. Now the second reaction, it can also be used with aldehydes. Even you can use them with aldehydes. Suppose if you have aldehydes and you use alkaline KMnO4. Okay. So then also you will get the same product, carboxylic. Okay. So understood the convergence?
Yes, sir.
Conversion
Yes, sir.
from alcohol to aldehyde, conversion from alcohol to carboxylic acid, and conversion from aldehyde to carboxylic acid.
Sir, we can also use acidified K2Cr2O7.
Yeah, instead of alkaline KMnO4, you can also use acidified K2Cr2O7, which is potassium dichromate. Okay. So instead of alkaline KMnO4, you can also use here acidified K2Cr2O7. This is potassium dichromate. It is also a strong oxidizing. Okay. Then how you will get carbon dioxide and water? How can you get carbon dioxide and water from alcohols?
By combustion.
By combustion. If you start burning the alcohols, then alcohols will get converted to carbon dioxide and water. So it will happen to all of them. You can burn all the alcohols, aldehydes, carboxylic acids, all of them, they can be burnt to carbon dioxide and water. Okay. So I hope you have understood this. Then the final reaction I write here, final reaction means so final reaction we have is for the conversion of any of them. You can either have alcohols or aldehydes or carboxylic acids. And they can be burnt in presence of oxygen to give us carbon dioxide and water. All of them can be burnt in presence of carbon dioxide, can be burnt in presence of oxygen to produce carbon dioxide and water. So I hope all of you have understood about the oxidation reaction. A very simple thing. There are just three or you can three ingredients or three what we call them as you have these three. I'm not remembering the name. What we call them? Okay, they are called as. Anyone remembers what do we call them?
What, sir?
CrO3, KMnO4, what name is given to all of
Catalyst,
them?
sir. Catalyst.
Yeah, they are the catalysts. Okay, all of them, they are the catalysts. And here you have to remember just the name of these three catalysts. Chromium anhydride, alkaline KMnO4, and acidified K2Cr2O7. Alkaline KMnO4 and acidified K2Cr2O7, they are equivalent to each other. Okay. Srilasya,
Yes, sir.
you're not giving any reply. This is not good. You are not giving out any replies. No answers. Amatur Rahman, do not go to the general formula of the all the functional groups. Okay, keep that general formula only up to hydrocarbons. Now see, the next topic is isomers. What are isomers? What are isomers? Isomers, these are compounds having the same molecular structure, having the same molecular formula, but different chemical formula. Okay. So what are the isomers? They are the compounds having the same molecular formula but different structural formula, not chemical. They have a different structural formula. So the structures may be different. The structures of each other, they may differ in the position of the isomers. They may differ in the position of the carbon chain. Okay. They may differ in the position of double bonds. They may differ in the position of triple bond. So all such will be isomers. And not only position, some of them also show you functional isomerism. Okay. So but here you basically have to see about the uh, structural isomerism, and that too only up to positional isomerism. Okay. So let's see some of the isomers that can be made over here. For example, we take this. So let's see this structure. Okay. So what's the name of this compound? Silasya, what's the name of this compound? Yeah, Srilasya, what is the name of the compound?
Yeah, don't know, sir.
Don't know. How many carbon atoms are there?
Sir.
How many?
4.
4. So which number we learned for the number 4? For number 4, what is the name?
Mute, sir.
Bute. So you will write the word bute. And is there any double bond between them?
Sir.
Yes. So you write it as butene.
Muting.
Okay. No branching and no functional group. So it will be just your butene. Okay. Now the same formula I can draw like this also. It can be CH. CH double bond. C single bond. C double bond. CH. Okay. Let's have only one double bond. So here you also have CH, CH2, CH3. Okay. So this is butene. This is also butene. If you see, its name is also butene. Okay, but they have differences that here in this one, you have the appearance of the double bond at the second carbon. Okay, here you have the appearance of of the same double bond at the first carbon. Okay, so they are isomers of each other. They are having the same molecular formula. If you see the molecular formula for butane, is you have C4 and H8. The formula for this one will also be C4H8. Got it?
Sir, how many total isomers will be for C4H8?
C4H8. Okay. So for C4H8, you can make some others also like this. Okay. And see H2, CH3, CH3. This is also C4H8. And these are the only possible isomers of C4H8. All of them, they are differing in their molecular formula, but they are differing in their structural formula, but they are having the same molecular formula. Okay.
Sir, we can
So
also do ring shape, right, sir?
which one?
Ring shape.
No, ring shape will not be there. Then it will not be butene.
Then be cyclobutene.
Then it will also not be cyclobutene. Even the
Okay.
cyclobutene will not have C4H8. You can make it and check, it will not
Ah,
be
right, sir.
C4H8. Okay. So when you are considering the isomers, do not go for the cyclic compounds.
Okay, sir.
Okay. So let's make the isomers of bromopentane. Let's make isomers of bromopentane. This is your task. Make the isomers of bromopentane. Srilasya, are you making any of the isomers?
Yes, sir.
Okay. See, you will have the structures. I'm drawing some of them. You can add more to it. So it's a bromopentane. That means there have to be five carbon atoms, and one bromine has to be added at any place. Then the second one, you can make something like this. You can change the position of bromine to second carbon and complete the chain. Okay, so this one. You can also make it on the third one like this. So here we make bromine. So all three are the isomers. They are the structural isomers of bromopentane. You can make still more. Okay. Right now we just change with the bromine group. You can also build a chain of this. Okay. If you try to make a chain of 5 carbon atoms like this with branching in it, so it can be like this CH.